Hi, everybody. Um, so this video is going to go over engineering ethics and the law. This is supposed to be part of a series for my engineering ethics class, so some material might sound out of context if you don't watch the rest of the videos. Repeat after me. Engineers in the fulfillment of their professional duties shall hold paramount the safety, health, and welfare of the public. Perform services only in areas of their competence. Issue public statements only in an objective and truthful manner. Act for each employer or client as faithful agents or trustees. Avoid deceptive acts. Conduct themselves honorably, responsibly, ethically, and lawfully so as to enhance the honor, reputation, and usefulness of the profession. All right. This is probably going to be a long lesson. I strongly recommend for the people who would be sitting in class to do this hand gesture to me. You make a flat plate with one hand, you make a pointer finger with the other hand, and start making a rotation as shown by this gentleman on the screen. This would tell me, or at least give me a warning, that we are approaching the 1 hour mark, because some of this material I would really like to do just once and not repeat myself. Okay, so the first thing we're going to talk about is plagiarism, and why we're talking about plagiarism. Why does the ethics professor care? So, one story that I've told a handful of times, and I'm going to tell it again, is about how fads and engineering and technology come and go. Now, when my father was an engineer at the University of Rhode Island, specifically when he was a student, a lot of professors were of the mindset and thought process that AutoCAD and SolidWorks were just a fad. They were a temporary thing, they weren't going to be around forever, and that they didn't really want to invest a lot of time and energy in learning and teaching about AutoCAD and SolidWorks. However, any of the engineers in this room, or any of the engineers watching, might know that they absolutely need to know how to use AutoCAD or SolidWorks to be a successful engineer. You can get a whole job just using SolidWorks. SolidWorks isn't going away. However, if you were to use SolidWorks or AutoCAD or ANSYS, OpenFOAM, MATLAB, C, C#, Java, any tool, specifically a computer tool, that you use to get your job done in an academic environment, you need to state that you used it. To a certain extent, you might also need to show how you used it. If you write a MATLAB code, you might actually need to provide the code you wrote. And you need to say what packages you used to make it work. So, if you decide to use the AI, and I firmly believe this is not a fad, that this is a permanent thing, you need to cite that you used it. I honestly believe that you probably will be allowed to use the AI in the real world environment once you graduate. I think it would be a detriment to you if I strictly forbid it. However, all of the old rules still apply. Just because we have AI doesn't mean we can throw away old requirements. The old requirements existed for a reason. If you use the AI, you need to state that you used it, and you need to state the manner in which you used it. In the real world, you're allowed to take your written report to me and say, can you proofread this? So far, what I've written doesn't meet your requirements. You're allowed to go to the library, or you're allowed to go to the Academic Enhancement Center and say, hey, can I get somebody's eyes on this to make sure I've done this right? You're allowed to do that. So I'm not going to tell you you can't use the AI for those tasks, because you're allowed to get help from people on those. The AI just does a very quick job of proofreading. You're allowed to use that. If you decide to use the AI to help you brainstorm, that is also acceptable. You are allowed to Google a brainstorming session. You're allowed to do that. I just need you to document that you did that. If I find that I get a submission that is clearly AI generated, and I have suspicion you don't know what it actually says, I will fail you. Plagiarism, which is strictly forbidden at the University of Rhode Island, means using someone else's work without giving them proper credit. That means in academic writing, plagiarism involves using words, ideas, or information from a source without citing it correctly. So, like I said, I don't mind that you use the AI, and to a certain extent, I strongly recommend you do use it. However, if you are to use it, you need to document that you used it. If you send me an email and the AI helped you write it, I want written in that email, augmented by AI. Preferably, I would like you to also state which AI you used. If English isn't your primary language, and some of the concepts we go over might be difficult for you to talk about, so you need to translate it to Spanish or German or Chinese first, then you do the assignment and then you translate it back to English for me, you need to state that you did that. Now, I'll be honest with you, I'd be willing to bet you're also supposed to be learning English as part of this class, but that's beyond the scope of what I'm allowed to criticize you on. But if you do use Google Translate for your work, you need to document translated by Google whatever, or whatever software you decide to use. All right? If I suspect this is what you did, though, you copy the prompt, you paste the prompt into ChatGPT, you copy the answer out, and then you send it to me, I'm going to fail you. I had three instances last semester where students used the AI to translate to their native language and then sent me their response. I almost failed them. I was almost going to do it. You feel free to find those people and talk to them. I really was going to do it. They showed me that they used the AI to translate, but they didn't cite it. I didn't want to be a jerk, but now that I've said it out loud, you guys now know. If you use Google Translate, if you use ChatGPT, if any software you use, if you don't cite it correctly, I will fail you. If you cite it, I'll congratulate you and move on. Okay. This is the actual academic requirement from the University of Rhode Island as of last semester. Okay, let's get to the real lesson here. Ethics, law, and engineering. Okay, so this is a really important topic. Engineering, the law, ethics, it's all very interesting. It's also very complex. You could probably get a whole degree in this subject. We don't have time for that, so we're not going to do that. We have a little over an hour to talk about it. So we're going to highlight the important pieces and move on. As an engineer, you're going to be responsible for designing things, creating things, maintaining things. And those things need to work, and they need to be efficient. However, and more importantly, they need to be safe. And they need to be compliant with relevant laws. How do you do that? Well, that's complicated. Engineers get paid well. The reason they get paid well is because of how complex this task is. Your engineering professors are giving you a very good training so you can be an engineer and do the technical side. And they're just hoping that you're going to be ethical, and they're hoping you'll be lawful. Doing all three of those things is not easy. We're going to go over some tools to get that done, but again, it's not going to be perfect because we don't have a ton of time to go over it. And not everything is covered by the law. There is some things that the law doesn't have an opinion on that are either ethical or unethical. But when the law does have an opinion on something, and you decide to violate it, it can and usually does have a very heavy hand in engineering applications. All right, so where does law and ethics overlap and where is it different? Well, the laws provide a framework of legal obligations. Ethics encompasses a broader moral responsibility, but like I said earlier, just because it's legal doesn't mean it's ethical. And just because it's illegal doesn't mean it's unethical. Ethical standards often inspire legal regulations, and legal compliance is a basic ethical duty. So, that is to say, as an engineer, even if you know a law is bogus, you are not allowed to approve something that will violate the law. There are instances where ethics and law complement each other. Ethics guide engineers to go beyond mere legal compliance, aiming for higher moral standards. Laws establish the minimum required safety standards for safety, fairness, and responsibility. Now, legal knowledge. Why are we talking about it? Well, the thing is, part of you becoming an engineer will also mean not just that you understand the physics of what you're doing, but the laws associated with the physics of what you're doing. And I don't mean Newton's laws. I mean, what is the American Society of Mechanical Engineers' opinion on pressure in a pipe inside of a building? It does have one. You're obligated to know that. And not that the ASME has an opinion, you need to know what the opinion is. If you were to design something that goes inside of a building, you need to know how to make that thing safe. So that means you need to know which encyclopedia for ASME you have to go to make sure the piping system's safe. You need to know which Code of Federal Regulations, CFR, to go to make sure you're complying with the laws. If you're working pharmaceuticals, you need to know what the FDA's opinion is and the International Society of Pharmaceutical Engineers' opinion is on it. If you want to build pipelines, gas pipelines, oil, petroleum, natural gas, you need to know what the American Petroleum Institute thinks on safety. You need to know this stuff. You can't call yourself a petroleum engineer unless you know what API says. You can't say you're a pharmaceutical engineer unless you know what ISPE says. You can't say you're an automotive engineer unless you know what the automotive industry says. So it's your job, once you get into the market, to figure that stuff out. We're not going to go over all of it because each and every one of those is a whole career. And again, I only have 60 minutes to go over this stuff. One last thing, though, is you are also obligated to understand common contracts within your industry. So that is to say, you are going to have laws, which is going to be more or less universal within your area, but you also need to understand contracts between pharmaceutical companies and their suppliers are going to be different than contracts between petroleum companies and their suppliers, and automotive companies and their suppliers. So you need to be aware of those uniquenesses of your contracts. So these are some engineering considerations. So you should know what OSHA's opinion is inside of a factory. What is OSHA going to say and why do they care? If you go to a construction site, you should also know what OSHA says about construction. I'll be honest with you, as a new engineer, you're not going to be expected to be a subject matter expert on this. You should be able to rely on the project engineer and the foreman for this stuff, but I would strongly recommend getting up to speed on OSHA's opinion on all of this stuff. You're not going to be required to be a subject matter expert on the environment when you first start your job. However, you better figure out which EPA rules apply to your organization while you're working for them so you can keep them out of trouble. And the next is patents. If you have any intention of ever getting a patent, now is the time to learn the patent laws for where you plan on living. I have a patent. I'm very proud of my patent. However, I couldn't have gotten it on my own. I needed the help of lawyers. And in reality, you most likely will too. All right, legal and ethical responsibilities. So the first thing is contracts. We need to know about contracts and how they work. Contract is just a written document. It's an explicit set of statements saying one organization is going to do this, that, and the other thing for this other organization for this, that, and the other thing. Typically, it's you're going to provide me a good or service for money, but typically there's a bunch of caveats in there. If you're buying screws, there are going to be requirements that need to be applied on that screw. There's probably some ASME code that you're going to use to say this is the kind of screw I want, and ASME will actually state for you the quality control measures that the provider needs to actually do. A lot of the contractual stuff, the contracts would be the size of encyclopedias if it weren't for things like ASME and ISO and all that jazz. But any project you're on, you better know what the contract actually says. So that means you need to go read it. If somebody starts asking you to do things and you do not know for a fact the contract says to do that, or if you do not know for a fact that the thing they're asking you to do is legal, go find somebody who you trust who can tell you otherwise. In engineering, contracts bind parties to their duties and rights, essential for project success. All right, so I forget whether I said this already or not, but we need to talk about legal liability. What is legal liability? What does that mean? It is what you are legally responsible for. Typically, it's for one's own actions or omissions of action in the engineering field. Common types of liability. First is negligence. This is when you do a bad job. Either because you've been directed to do a bad job, or you were just not paying attention, or you were being lazy, but you've done something bad, something you knew not to do, or you had the skill set to prevent, and you didn't. The next is breach of contract. This is failing to fulfill terms as outlined in a contract. What does that mean? So, if you are contracted to supply screws that are 4 inches long, and you supply screws that are 3 inches long, that is a breach of contract. Now, typically in the real world, if you do this, it's an accident. There's some communication back and forth. You take the bad screws back, and then you give them the screws that they want. However, sometimes there's disputes. Sometimes you give them exactly what they asked for, and they didn't realize that they were asking for the wrong thing. And there are instances where somebody was selling something knowing that the consumer wanted something else, and they just didn't know the right terms, but didn't correct them and sold them the wrong stuff. Depending on how inconvenient this is, you might be liable. Now, this is an oversimplification, but if I walked up to you and said, I've got 10 4-inch holes, and I would like to buy 10 3-inch screws, and you sat there and thought for a minute and said, I'm pretty sure he wants 4-inch screws, there are instances where you would be legally liable for selling me the 3-inch screws, even though I've asked for them, if you know that I should be getting the 4-inch screws to do my job correctly. So there is some level of due diligence expected on your end when you are working out some of these contracts. Violation of the laws and regulations. Now this one's interesting because sometimes it's an accident. But even if it is an accident and you do not comply with industry standards, safety regulations, or the law, you can become liable. Now there are special instances where sometimes within the contract it's written that you will violate the law, which makes the contract null and void. But you do need to make sure that you are fully aware of all of the laws. Now, having said that, when you first get hired, this is not really going to be an expectation that's held on you. You're going to be working with people who should have this experience, who should be able to do this in their sleep. And you will eventually get to this point. But as you're going through your job, once you have your career going, be prepped to be asking these questions. What laws are we following? What rules, what specifications do we need to comply with? It puts you in a situation where you can hit the ground running faster, you can be a functioning engineer by yourself sooner, and more promotable. Consequences of legal liability. Well, the most common one is financial penalties. And usually this ends up getting absorbed by your parent company. In all honesty, if they put you in a situation where you can get somebody hurt, they're being negligent. However, that usually doesn't happen. Usually you just break stuff. And at that point you need to pay for it. And again, that usually ends up getting absorbed by your parent company. If what you did is grossly negligent, that is to say your company itself comes to you and says, hey, you should have known not to do that, they can start the motions to get your license revoked. Depending on what industry you're in, you can get kicked out. If you violate specific FDA rules, that is falsifying information on a batch record, you can get kicked out from pharmaceuticals and biomedicals. You will be forbidden from working on those projects, and the FDA will not allow companies to sell products that you had a hand in. And in those instances, you have damaged your reputation. Sometimes you cannot fix that. Now, there are special instances where your parent company doesn't protect you. These are instances of gross negligence. That is to say, you knew that the design was going to fail, and you approved it anyway. This doesn't happen often, but usually there is malintentions in the action. So if you say something is safe, and you do not have the objective quality evidence to prove, to validate that it's safe, that might be considered gross negligence. It happens frequently in drug companies. If you do not have proof that what you're saying is right, it needs to be treated as if it's wrong. All right. There's various levels of responsibility or liability. There's personal responsibility. You are obligated to uphold ethical standards, comply with laws, and maintain competence. That's your job. That is always your job. And then there's the organizational responsibilities. Organizations are required to uphold ethical standards and legal compliance. It more or less sounds like it's the same thing, doesn't it? It's because you're both responsible. All right, these are examples of legal liability in engineering. The first is the Hyatt Regency walkway collapse. This happened in 1981. The engineers involved designed the walkway one way. It got built a different way, and then the engineers never had it corrected. Now, this is a typical practice within engineering where the engineers will design something. The people who are building it will come back to the engineers and say, you've designed something that's unconstructible. Can we make a modification to it? There'll be some back and forth about what can actually be made versus what will actually meet the requirements. And then you'll come to some agreement in the middle, and you build that. And then the engineers will document the new design, and then they'll do the engineering calculations to show that it's safe. And that's when people are allowed to use said things, in this case, a building. That last step never happened. And it's suspicious that it didn't happen, because it looks like, at least the paper trail leads people to believe it did happen, and the paperwork just went missing. And so that's how it got treated. So the engineer lost his license and faced significant financial penalties. He was strictly forbidden from working for the rest of his life. Now, granted, he was close to retirement anyway. That is what happened. The next is the Deepwater Horizon oil spill. Again, the engineers involved in the design and operation of the oil rig were found to be legally liable for the spill. And the company faced billions of dollars in fines and settlement fees. Now, this is the Hyatt Regency walkway design. Now, the original design was not this. This was the end product. Now, you can't really tell from this image, but the amount of weight on that one bolt on the bottom is equivalent to, number one, the bridge that it's currently holding, and the bridge below it. In the original design, it would have only supported the weight of the one bridge. In the redesign, the number of supports were cut in half, and they changed the way the bolts were arranged. So people were dancing on this walkway, and then one of the poles became disconnected. I forget whether it became disconnected from the ceiling or from the walkway. But once one failed, they all failed simultaneously, causing everybody on the bottom floor to die. And then it caused the people who had been on the second floor to be on the bottom floor, but then the third floor also lost and fell and landed on the people on the second floor. This caused about 114 people to die. Everybody involved, the engineers, fabricators, constructors, they were all held liable for negligence. This slide is for the Deepwater Horizon oil spill. So what they had was called a blowout. Basically a large pressure buildup occurred. These are not all that uncommon in what they were doing. But in this particular instance, the blowout became uncontrollable. This caused a series of explosions and a subsequent fire, sinking the entire drilling rig. Unfortunately, when the rig went down, 3.2 million barrels of oil spilled into the Gulf. And this became a massive environmental problem. Now, the reason this happened is quite interesting, and again, we only have a limited amount of time to talk about it, but it was because of gross negligence. The engineers who knew better approved things that they knew they shouldn't be approving. Now, this brings up an important point. We need regulations. They exist for a reason. A lot of times the regulations exist because somebody else screwed up. Somebody died. A lot of damage was caused. People got hurt. You don't want to repeat somebody else's mistakes. So use them. Use the regulations. Use the standards. Interesting story came from ASME, or more specifically, why it came into existence at all. So the beginning of the century, the 1900s, natural gas had just been figured out in the sense that they figured out they could harness it, put it into pipelines, pump it from Texas to New York City. This was great news. This was a big deal. However, the pipelines kept failing, specifically in New York City. It's caused a lot of people to die. Caused a lot of people to get hurt. And so the city of New York was trying to find a way to solve this problem. They knew that they couldn't get rid of natural gas. They knew it was there to stay, but they wanted to regulate it so nobody would get hurt. And so they started passing a bunch of laws. And unfortunately for politicians, they're not very good engineers. And being that engineering is the merger of science and business, you'd imagine they'd at least have done better, but no, they did a very bad job because they didn't understand the physics, they didn't understand the business side of anything that was going on. And so they kept passing laws, and a lot of laws didn't make sense. Even if you complied with it, you didn't make the system any safer. And honestly, some of the laws that were proposed, instead of, let's make sure that the engineers are certified, that they know what they're doing, let's make sure the welders know what they're doing, it was, let's only let my cousin Vinny's construction company build the pipelines from now on, were some of the actual proposals, right? Eventually, the city of New York came up with one good idea that cascaded and caused a bunch of other good things to happen, which was every pipeline needed to be insured. Not only that, it needed to insure against the risk of destroying everything next to the pipeline. Well, at this point, insurance companies got involved, and the insurance companies started guessing how much damage that pipe could cause. And the owner of that pipe had to pay the insurance company to maintain it. Well, how does an insurance company estimate how safe a pipe is or isn't? Well, they went and found an industrial code managed by the American Society of Mechanical Engineers. And they said, we will only insure pipes that have been built to this set of standards. And all the explosions stopped happening. Insurance company wants to get paid, they do not want to pay. So they made sure that the pipes wouldn't blow up. Well, the city of New York thought this was a really good idea, so they started applying it to other stuff. And instead of requiring the insurance company to insure everything, nowadays I'm sure that is the case, but at the time it wasn't, they just said, instead of us making the building codes, we're just going to say follow ASME's codes. And whatever ASME decides to do is what you have to follow. And after that, the rest of the federal government followed suit. And that is where the existence of ASME came from. All right. Now, how does ethics get involved in that? Well, the good thing about people who make the codes is they kind of know how frustrating it is to read the codes. They also know how frustrating it is to read the laws. So they do acknowledge that what they're talking about does not cover everything, and that you do need to think about what you're doing. And so they do have sections on this is how you need to be ethical, so that way you can think on your own. Yeah. All right. So now we're going to talk about work culture. Now, Now, before I get into this, I need to talk about one issue I have with work culture and management and some of the stuff that the books have to say about the law that I take issue with. In all of the books, and I've read 4 books when making these slides about engineering and the law and management and all that fun stuff, all of them live in this fantasy world where your boss is never going to ask you to do anything outright illegal. And your boss is always going to be listening. And your boss is not going to throw you under the bus. And your boss is going to do all of the right things in all of the right ways at the right time to the right people. And I can tell you from personal experience, your boss is going to tell you to do something illegal. Your boss is going to get mad at you when you refuse. Your boss is going to throw you under the bus when the illegal thing you refused to do became clear that it was now his problem. Your boss is going to be a problem. And you need to learn how to protect yourself from when your boss and your company tries to get you to do something wrong. There are going to be instances where the people around you are toxic, not safe. There's going to be instances where people are going to try to stab you in the back. You do not live in an ideal world. You live in the real world, where your coworkers might not care about you, where your boss will treat you like a piece of meat to be used and thrown away. If you find that you are in that scenario, where your boss is a piece of crap, where your coworkers are terrible, you need to understand that it's not you. If you find yourself in this situation, I want you to go to your phone and I want you to call me. I will help you. You do not deserve to be treated like that. So, from the book, High Ideals, Perfect World, you have to remember that your company's organization and its culture affects your behavior and your decisions. They're supposed to have a collective set of values and beliefs and norms that drive you and your organization towards success. They're supposed to. And that culture is supposed to influence how successful you are, how successful the team is, and shows you how to handle risks and ethics. Supposed to. And all this stuff affects your decision-making process. Some organizations take higher risks for higher gains. And that's okay if that's how your organization is structured. Some organizations can't do that. If you work for, say, the military, their tolerance for risk is practically zero, because they know from time to time they're going to be walking into extremely risky situations. If, however, you work for, say, an oil company, their tolerance for risk might be enormous because they can absorb that risk and that failure. You're going to run into challenges when your level of risk that you're willing to assume and how safe you want to be clashes with your organizations. Now, if you are in an ethical climate, that is to say, your boss is ethical, your company is ethical, your coworkers are ethical, you're going to have a couple green flags. Good signs, things that you should be happy to see. First is a clearly defined set of standards and values. Look, you don't need to agree with them, but they need to be there so that at least you know what direction to be going. Look, at the end of the day, as long as you get paid, if the company wants to take a big risk, let them. That's not your problem. The leadership is ethical. That is to say, when you go to work, you have high things to say about the people you work for. I say very good things about the NIUVT and the people I work for within the NIUVT. They're very ethical. They do the right thing. I've worked at other places where I couldn't stand Stan. He went out of his way to be disrespectful and throw people under the bus. I don't like talking about him. I like talking about the people I work with at the NIUVT. You have protection from retaliation in ethical climates. That is to say, management protects the employees from other management and other employees. So if something unethical is happening, you're in a situation where you can report it and you can document it. I've been told directly by management before, not here at URI obviously, but other places, after having a meeting and taking the notes and sending the notes out, that I should stop doing that because it holds people accountable for the things they say and do and promise. I found out later it wasn't really because taking notes is bad, which is what I was told at the time, but it was because it put a handful of people in a position where they actually had to deliver on their promises, and they didn't like that. There's a fair and transparent set of policies and practices. This is most obvious when it comes to promotions. If somebody gets a promotion and you don't, and you go ask why, and you're allowed to ask why, they will clearly explain why. Look, sometimes your skills that you're very good at aren't necessarily what they need at that time. And that happens, and that's unfortunate, and it's frustrating. But you're allowed to ask. And if you go ask, and they get mad at you for any reason, probably not being ethical. You should be able to ask the 5 whys in an ethical environment about anything. So going and saying, why didn't I get that promotion? Why did he get that promotion? Shouldn't be a problem. And if it is, there's probably an ethical problem going on there. There is a defined ethical decision-making process. Usually this is in the employee handbook. It's a red flag if they don't even have one. Leadership takes more responsibility for failures. So I've dealt with this, and I'm sure most people in the room who've had a job for more than a month have had to deal with this. They had some manager give them very explicit, very direct instructions on how to do something, and you did it to the T. And it didn't work. And it didn't work because your manager was either an idiot or lazy or didn't know what they were talking about or just shouldn't have been doing their job. But instead of saying, hey, sorry I gave you bad directions, or sorry the directions I gave you weren't accurate, or anything like that, they just throw you under the bus. They say it's your fault, even though it clearly wasn't. I've had instances where I wasn't even in on that day when something bad happened, but somehow they tried to blame me for it, instead of leadership just saying, hey, we screwed up. In addition, the reverse is also true. When you have big successes, leadership should go out of their way to minimize the amount of credit they take. If you find that when things go well, management is taking more credit, and when things go bad, they take less credit, they're probably not a very ethical bunch of people to be working with. A good sign is if they have some kind of social and environmental responsibility program. Last semester, I had somebody who got hired by General Electric. General Electric has an actual, it's not SWE, but it's a branch that acts like SWE. And when they bring new people on, they try to encourage them to participate in these diversity events. That's a really good sign. If they don't have something like this, it's a really bad sign. Other organizations like Raytheon do the same thing. They recognize the value of diversity. So having more women on the team, having more people of color on the team, this is a good sign. If you're only working with white men, there's a really good chance there's an unethical reason for that. And lastly, there's a stakeholder focus. Now, this doesn't just mean just employees. Stakeholders are the investors, the consumers, the customers. And keep in mind, customers and consumers aren't always the same people. And then the employees and suppliers. Having a stakeholder focus means you go out of your way to make sure all of those people are happy. And the reality is, if any one of those people is unhappy, the overall program is going to suffer. And if it suffers enough, it will fail. So if it becomes clear that corporate doesn't care about, say, the employees are going to quit. They're going to stop working, and the quality of the goods are going to go down, or the cost is going to go crazy high. Or they stop doing what the customer wants, so the customer stops paying. I need to be clear in this discussion. When I say stakeholder, I am not talking about management. There are exceptions to what I'm about to say, but the vast majority of the time, management is replaceable, and they should be paid as such. These are signs you are in a toxic work environment. According to the books that you have for engineering ethics, this doesn't exist. And I'd be doing you a disservice if I entertained that idea. A lot of you are going to walk out of here and walk into a toxic work environment. These are the signs to identify it. First is there's a high level of stress. Everyone who's watching this video is trying to become an engineer. Engineers do not work in emergency rooms. They do not work in a firefight. They do not work on the trading floor. They do not buy and sell stocks at any given moment. What they do is they plan and they design and they discuss and they meet. So if, for some reason, somebody is putting you in a high stress situation where you have to have an answer now, you need to prepare to walk away. There is no reason you should be in that situation as an engineer. You should always be in a situation to say, I don't know, I need to think about it, I will get back to you. And you need to be able to allot a reasonable amount of time to think about it. The reason people like to put you in high stress situations is to burn you, to make you make a bad decision. And there is no good reason to be doing that, especially considering a lot of the things you do, if done wrong, will kill somebody. There's lack of trust. You need to be able to trust your boss. You need to be able to trust your coworkers. You need to be able to trust everybody. Your suppliers, your customer. You need to be able to trust everybody. I have worked in situations where I couldn't trust my boss or the departments I was working with or our regulators. And I'm not exaggerating this. It became clear to the quality control department that by sitting on a task and not getting it done, I would get a bonus, and neither would my boss. So they just refused to do it. This is not a healthy situation to be in. There should be no reason that they enjoy that scenario, but they did. Further, I didn't like doing anything for my boss, not because I didn't like doing the work. I like doing work. It gives me something to do, something to be proud of. It was because I knew a lot of his directions he had provided to me were either wrong or were going to cause a problem. And he hadn't addressed those problems yet. And when it came time to addressing those problems, instead of acknowledging that there was going to be a problem and that he knew about it ahead of time, he would just throw me under the bus. And so I'd bend over backwards to try to minimize those things, but at the end of the day, I knew there were landmines he wasn't telling me about. There's lack of cooperation and support. Look, there's the chances that you're going to be working for a small company is not very high. It's possible, but it's unlikely. You're going to be working for somewhere that has an engineering department, a manufacturing department, a quality control department, finance, all that stuff. And if you're given a project and you can clearly identify there's a logistics task, but you're not a logistics person because you're an engineer, you should be able to take that chunk of work and walk it over to the other department and say, hey, I need help with this, and find somebody to hand it off to. But if you work for an organization that doesn't let you do that, there's an unhealthy reason that they're being combative. The next is any level of micromanagement or autocracy. So micromanagement is when your boss stands over your shoulder and literally tells you how to press the keyboard and doesn't actually let you do any of the work without him yelling at you. Autocratic leadership, on the other hand, is telling you have to do something because they're more important than you. I'm a firm believer, and I've definitely seen this here at URI, that if somebody needs to tell you that they're important, they probably aren't. If there's any bullying or harassment, especially if it's tolerated or protected, I would even venture to say if you experience this is well within your rights to go get a lawyer. If there's high turnover, anybody who's worked at a restaurant has probably dealt with everything above already and knows that there's high turnover. If they do not respect your work-life balance, you, at the end of the day, when you go home and you go see your family, that should be the end of that discussion. I've had bosses call me at midnight because they were pissed at me for this, that, and the other reason. I've had bosses call me 30 times within 2 minutes because, well, they said that what they were trying to do was super, super important, but it was definitively not. If you hear the line, but that's how we've always done it, that is a toxic statement. Look, you live in the US, you're going to probably work in the US. If you work globally, you're going to have to work in a very competitive environment. To be competitive, you have to be dynamic. Dynamic, by definition, means you change. That means the statement, but that's how we've always done it, shouldn't apply. Typically, the reason somebody says something like that is because I don't want to change, I don't want to get better, I don't want somebody learning what I'm doing, I want to keep doing the bare minimum and keep my job. And last, if there's any absence of accountability, that is to say, if your boss likes to throw you under the bus, if you do work and it's successful and something to be proud of and they try to take it away from you and say, no, it belongs to this other guy, it's toxic. The next is loyalty. Toxic work environments love to abuse loyalty. Now, there's two types of loyalty that most people are familiar with that are more or less apply to work. The first one is called agency loyalty. This is more or less your ability to keep your promises. If you are contracted to do something, that means you've made a written promise to get something done. You got to do it. If you have a high agency loyalty, it means anything you say you're going to do, you're going to do. This tends to be loyalty to engineering. You've made a bunch of promises that you're going to be ethical. Keep it. The next is attitude loyalty. Now, in this instance, instead of keeping your promises, it's you identify as being an engineer. You want to embody the idea of being an engineer. Now, the company you work for wants you to embody the idea of working for them. And that's, it's not a terrible way to go about doing things. But there's a right way and a wrong way to do that. You should be passionate about your work. You should identify as being an employee at that company. You should be proud of wherever you work. A handful of instances where if they try to use loyalty as a justification to make you do something, you should be critical of what they're saying. Now, what people like to do when it comes to loyalty is exploit you. Look, if you want to be a proud engineer here at Shell, you better be prepped to work in dangerous work environments. Hey, if you want to be a proud engineer here at Amazon, get prepped to be paid dirt. Hey, if you want to be a proud engineer here at Apple, be prepped to do the same job for the rest of your life. These are all things, no, I'm saying companies you're familiar with. I don't know whether they actually did them or not. But these are all things that people will say to try to get you to think less of yourself. In none of these instances do any of you deserve this. You are well within your rights to say, I should be feeling safe at work. I should be being paid a fair amount of money for the work I'm doing. If I don't see an opportunity for growth in the next 2 years, I'm gone. I'm finding somewhere else to go. You've asked me to do 90 hours worth of work in the next 2 days, which is physically impossible, let alone reasonable. You're trying to dock my pay because I refused to do something illegal. Last, the manipulative management tactic. This tends to be some form of manipulation, coercion, or intimidation. Fortunately, I don't have a written explanation of what that might be right now, so I'm sorry. So, there is a relationship that engineers and managers are supposed to have. And they are supposed to work together, and they are supposed to like each other. Now, the engineer's job is to focus on the technical expertise, the innovation. And they're supposed to ensure that what they're doing is safe and efficient. They do need to adhere to ethical and professional standards. Manager's job, on the other hand, is a bit different. Their focus is on project management, resource allocation, and meeting organizational goals. And they have to balance profitability with ethical considerations and public welfare. Now, these two groups need to work with each other, and they need to make an attempt. And sometimes that's going to be hard, but you have to. You have to find a way to make it work. Sometimes that way is you leaving, but you have to find a way to make it work. Now, I'm not saying all managers are bad, because that's a false statement. But you as an engineer do need to protect yourself from when a manager goes on the offensive. So you also need to keep in mind management is probably the most common direction that engineers go in terms of promotion paths. Realistically, there's only really 3 paths that an engineer can take to promotion. The first one is becoming a manager. I want you to look at your grades right now. If you expect to graduate with somewhere between a 2.5 and a 3.3, you are most likely going to be a manager. If you have a 3.3 to a 3.8, you are probably going to be some kind of lead engineer, subject matter expert. If you have anything over a 3.8, you are probably going to do specialized research, which might sound good right now, but is actually not as good as you think it's going to be. It also usually means that you're difficult to work with. General public doesn't want to work with you. And only when you deliver very good products are they willing to give you money. However, the lead engineer, the subject matter expert, he's the one who gets contracted by General Electric, General Motors, Ford, Apple, IBM. He's the one who actually gives the good advice because he can actually work with everybody. He can work with the other engineers in different fields. He knows to a certain extent what management actually wants. He actually understands the needs of the customer. When the customer comes back to him and says, hey, when I use this product wrong, it doesn't work the way I want it to. And he can actually deal with that. PhD is not gonna. PhD is just gonna say, just use it right, which isn't a real solution in a real world environment. The real solution is you either make the product unusable when you use it wrong, or you make the product more usable. Now the manager, it's a unique situation. So how it usually goes is you've got 10 engineers working on a project. And they have limited resources, so really only 4 or 5 engineers can put their nose to the grindstone and actually solve the problem. So then you have the manager who he's going to let the subject matter expert do that. But then he looks, what other resources do we have that we don't know we have? So he goes to the scheduling people and says, when do you actually need a solution by? What's the real date? Like, yeah, you told us to get it done in the next 2 weeks, but is it really in the next 2 weeks? If we got it to you tomorrow, would there be a better solution for you? Is there some flexibility? If we can't get it done in 2 weeks, is there a different due date? And they go to the finance department and say, how much money are you actually willing to spend to fix this problem? If you're willing to pay for it to go away, we can make it go away today. But if we can't afford to make it go away with money, yeah, then we'll find another solution. Could we buy a tool to make this easier? Would that be a possibility? But then they go to management, and they go to the customers, and they talk to all of those people. And then they find a couple solutions that are non-engineering solutions that are still feasible. And then they go back to the lead engineer person and say, I see that you found a solution, but I also have these other 3 solutions. I think we should present all of them at once. So that way, there's some kind of happy medium, because that's really what management wants. They don't want, this is the one solution you have to do. They want options. And this type of behavior gets them that set of options. Now, the lead engineer also has much different goals than the management team. The engineers almost always heavily favor high quality. This has some cons. One of them is cost. Now, normally there's confusion. People assume high cost means high quality, which isn't the case, but typically high quality does lead to high costs. Management, on the other hand, understands that not only do they have a fixed budget, but they have a fixed schedule. And sometimes they have to go to the engineers and say, look, the quality you're talking about is both too expensive and it's too far in the future. We can't be competitive at that quality. You have to bring it down somehow. And they have to work together. Now, one observation I have made between engineers and management is if management has little or no engineering or technical background, the fights get bad. To the point that in some instances in biomedical device companies, entire branches have threatened to quit because management was setting deadlines and schedules that were basically illegal. There's a whole process to get something approved by the FDA, and if the FDA has never approved something in less than 6 months, it doesn't make sense to say the product's going to be ready in 5. Not only that, if you try to sell something without the FDA approval,
you can't go to jail. And so there have been instances where they basically had to kick managers out because they were so uneducated. All right. So as an engineer, you do have some moral responsibilities, and you do need to maintain some level of record keeping. So this is just a general statement. This is a good practice that you should probably get into now, is taking notes. So you're going to have meetings. You should write down as much as you can from those meetings. And at the end of the meeting, send the notes out to everybody in the meeting. And in the subject line, put the words meeting minutes. If somebody has a hissy fit about receiving an email from you that has the words meeting minutes in it, they better have a really good reason. I have never been in a situation where sending out meeting minutes has caused a real problem, with the exception of when someone is blatantly trying to be unethical. So you should start doing that now. Also, by doing that, it holds people accountable. Look, if you write in the minutes, Joe promised to get something done by next Friday, the next time you have that meeting, and you go to your minutes and you say, hey, Joe said he was going to get this thing done. Why isn't it done, Joe? It becomes clear that the reason the project's being held up isn't because of you, it's because Joe's not doing his job. The next is, as an engineer, you need to make an attempt to overcome Milgram's obedience problem. Being that when I taught this class last time, and I brought this up, only 1 out of 90 students knew what this was. I'm going to quickly explain it. If somebody of authority tells you to do something, you are probably going to do it, even if it's horrific. That is to say, I, as your ethics professor at URI, if I were to tell you to kill somebody because your grade required it, you'd probably consider doing it. So how do you overcome Milgram's obedience problem? Well, like I said earlier, take notes. And once you've written those notes down, compare them against the company's mission statement and the company's values. If they're obviously in contradiction to each other, that's when you say, hey, boss, can you reconcile this contradiction? And if they can't, or if they get fussy about it, there's a good chance they're being dishonest or unethical. At that point, that's when you go up to higher management. You need to document issues. All right, maybe the confrontation or discussion you had wasn't a real meeting. That doesn't mean you don't still go back to your desk, write down what the discussion was, and email it. Personally, at URI, I can't tell you how many times I've had a discussion with somebody. I immediately went back to my desk, wrote down the whole conversation we had, and said, hey, Adam, per discussion, you said da. Thank you very much. That was very helpful. I think your boss should give you a pat in the back. Look, I wasn't sending that email because I thought Adam needed a pat in the back. I sent that email to write down what Adam had said and that I was using it to move forward. When people later fussed about it, I pointed out, hey, I sent out this email and you responded to it. You clearly read it. You clearly saw what I was going to do. Why didn't you say something then? All right. So how do you navigate ethical dilemmas? Well, what is a dilemma? So I know I went over it at the beginning of the semester. I'm going to go over it again because this tends to be a hard concept for people to understand. A dilemma is a situation where there are conflicting ethical principles or values. These tend to be catch-22s. Damned if you do, damned if you don't. Sometimes these conflicts are over costs and safety and confidentiality and public interest. You have to make a decision. How do you do that? How do you identify what the next right thing is? So you have to come up with some system, some framework to move forward. Now, the section is contracts and the law, so right now all I want you to worry about is what the law actually says and what codes and standards tell you to do. Proper decision making. You as an engineer need to make decisions. You're not getting paid to ask your boss what you guys should be doing. You're getting paid to give a recommendation to your boss. You're giving him direction on what you think they should be doing. So you have to use your technical knowledge and training to do that. But you still need to meet technical codes, ethical codes, and legal codes. All of these codes I just referenced mentioned this idea of loyalty. And again, some people are going to try to abuse it. Now, the book and a lot of the engineering codes refer to this as critical loyalty. But critical loyalty is a mixture of the two loyalties I mentioned in the previous slides. And you need to prioritize your profession over the company. You need to be loyal to engineering. You don't need to be loyal to General Electric. You don't need to be loyal to Raytheon. You don't need to be loyal to IBM. You need to be loyal to engineering. And you must advise on the quality of the product. Now, if you see a problem with a product, either from an ethical standpoint, a functional standpoint, a cost standpoint, you need to identify it ahead of time. You're not getting paid to realize it doesn't work after the fact. You're getting paid to show that it will work later. So that means you need to communicate problems when you see them, the moment you see them. So that is to say, if you go to the factory floor and you pick up one of the products and you try to use it and it doesn't work, you go back to your desk and you write that shit down. Hey, I picked up this toy. Toy's arms don't work. In the advertisement that we're selling it in, we say it does. You write it down and then you email it out saying, hey, what's going on here? After that, that's when you try to fix it. Now, on the other side of it, there's managers. Now, again, this is the idyllic version of a manager. Unfortunately, you're not always going to be working with these guys, but they're a custodian of the company. So that means they need to prioritize the company's welfare, keep the company in business, make sure the company makes money, make sure the company pays you. The manager is supposed to worry about the future of the company, the employee morale, and the public image. And all of their decisions need to factor in cost, schedule, and quality. Not just quality like the engineers want them to. Lastly, when an engineer tells a manager about a problem that needs to be fixed, the engineer provides a solution, the manager needs to work with the other branches to make sure it gets done. If the manager insists on refusing to listen, there's a problem. Engine conflicts. This happens. Now, again, this is the idyllic version. This is when the manager has a problem because the engineer can't find a solution that's cost-effective or within scheduled time. I'll be honest with you. I've dealt with managers who did not like the fact that 2 plus 2 was 4. They needed 2 plus 2 to equal 10. And they needed me to do some magic to get us there. And it didn't matter how much effort I put in showing, look, we can get you what you want. It's just this isn't the path to get there. Didn't matter. And I'll be honest with you. If I figure out how to solve that problem, I'll let you know. But when there is a conflict of interest, you need to document everything. You need to document why your position exists. You need to document why management's position exists. And you need to do it objectively. That is to say, you can't say management's a bunch of selfish dummies. You actually have to say something to the effect of management only has so much money and needs to get the problem solved in a month. You need to have an effective dialogue. Sometimes management's asking for the impossible, and you need to make that clear. So that means not only do you have to get management involved, you have to get the customer involved and be like, hey, look, I know management promised you this, but we can't deliver on that. Is there somewhere in the middle we can meet? All right. So this is a video. I'm going to keep going, but this is the hour and 15 mark where I wouldn't be able to hang on to the students anymore. So, I talk about identifying an ethical issue. Now, right now in this section, we've only gone over social contract theory. There are other ethical frameworks. We're not really going to go over them right now because social contract theory covers enough. There's enough laws and codes and things like that to get the point across here. But if you take the rest of the class, it might be worth coming back to these slides and rewatching this one section. So the first thing you need to do is gather as much information that is feasibly possible about the issue. So that means doing your research. Research means, at the very least, Googling the problem. You ask questions. You go find subject matter experts and ask them what they did. And then you need to consider the bigger picture. You need to figure out who's involved and why they care. I can't tell you how many projects I was on. I realized half of the voices were people who didn't stand to gain or lose anything. They were just there talking. You have to take Occam's razor and remove those people. Look, if they're just voices, get rid of them. If they're stakeholders, if they're paying for it or they're building it or they're using it or something like that, yeah, get them involved. But, if you're building something in Rhode Island and somebody in California who never is going to leave the West Coast starts complaining about it, do you really need to care what they say? You need to understand all the stakeholders' cares. Why do they care? What are their issues? You actually need to empathize with them. You need to see their point of view. And it needs to be their point of view. It can't just be, oh, my manager is an evil boss. You need to be respectful of diversity. This one, along with empathy, tends to be the biggest hurdle for people. And I don't mean diversity in the racial sense. I mean diversity in the work background sense. If you're building something, you need a construction worker. And if you tell him to do something he knows can't be done, or needs special tools that you refuse to provide to him, he's going to make your life hard. And you probably deserve it. So you get his point of view. You ask him, how do you want to build this thing? What would you do? What tools would you go get if you had an unlimited budget? You need to understand the impact of your decisions. So that means you have to do a risk assessment. If we don't do it in this class, I will show you how to do it in a different one. You need to consider the long-term impacts of your actions. Then you need to generate and evaluate your options. You might need to brainstorm, you might need to mind map, you might need to do SWOT, 6 hats, or Scamper. Be honest with you, as long as you do one and you document it correctly, you're probably fine. You don't need to do all of them. You just need to show that you've genuinely thought about the problem and you have genuinely tried to fix it. So what's brainstorming? So I know you've all heard it, but what does it actually mean? So you need to assemble a team, at least 3 people, but more the merrier. And you need to hopefully make sure they have different perspectives. More perspective means more solutions, which generally leads to a better outcome. You have to set some rules. You have to have some target, some end goal. You need to make it clear that you're not going to criticize, you're not going to fight or debate. You need to be open to exaggerated or wild ideas. Your focus here is the quantity of solutions, not the quality of solutions. And you do this in waves. So as a group of 3, you would say, all right, everybody needs to come up with 4 solutions to this problem. We're all engineers, so we're going to write down 2 technical solutions, and then we're going to write down 2 non-technical solutions. Everybody goes, so now you should have 12 solutions. You might repeat some, you might have very outlandish solutions. First, you grab the ones you repeated. You put them aside. And then you start evaluating the outlandish ones. And you see if any of them might work. Or you say, what do I need to do to make this work? And then you put it aside. And then you do another brainstorming, but building on top of the outlandish ideas or building on top of the ideas that everybody kind of agreed on. And you keep doing this until you think you've got a good solution. Mind mapping. So mind mapping is a visual technique for organizing information, generating ideas, and understanding complex concepts. It involves creating a central node with a main idea or topic and then branching out with related ideas or subtopics. So start at the center, write the main topic or idea at the center with a blank page. This gives you the brain freedom to spread out in all directions, express itself more freely and naturally. Use images as needed, use colors, connect the main branches as needed, add secondary branches, so on and so forth. This will give you at least a map of what's going on and possible solutions. SWOT. This one's more direct, but again, it's just as effective. Some people consider it less creative, but sometimes when you're in a time crunch, creative is not necessarily the best solution. There's 6 hats. This one is unique in the sense that instead of getting 6 people with different perspectives, you get 6 people and say, all right, you're going to play the character of feeling and intuition. You're going to play the character of optimism, so on and so forth, right? And it's strange, but telling somebody that they're going to play an empathetic character, even if they're not an empathetic person, makes them more apt to be empathetic. And gives you a more diverse set of solutions from a group that normally wouldn't be diverse. Scamper, substitute, combine, adapt, modify, put together, eliminate, reverse. This is another type of, like, it's a cross between SWOT and brainstorming, but again, it's just as effective. I wouldn't necessarily say you need to do all of them when you're trying to solve or make a decision, but I would at least do one, maybe do 2 in combination. But as long as you document that you've actually thought about it, gets you 90% of the way there. All right, the next is you actually have to make a decision. Look, you're not getting paid to think, you're getting paid to make decisions. So you have to do it. So you've just gone through the exercise of figuring out what your actual options are. Now you evaluate each option. You consider the consequences of each option. You check the practicality of each option. If you know your boss is going to say no, that's not a practical solution, is it? You make sure what you're doing is in line with your values and the company's values. You seek advice. You go get somebody who has not helped you up to this point and say, what do you think? I have a luxury where my wife is also an engineer, so when I'm doing some technical stuff, I can go to her and be like, how would you handle this? Go find your version of Sarah. Be prepped to do this with her from time to time. Make a decision. And last is review and learn. So this is more of a after the fact, do lessons learned. Now, before you execute, before you make the decision, you need to go through these tests. It's what I'm suggesting on to harm somebody. If this becomes public, am I going to enjoy being in the spotlight? Would I be able to defend my decision in front of a judge? I need to be clear with everybody in the room right now. What you're going to do is going to become public. This is not a maybe. When your books were written, it was a maybe. When your books were written, Phones didn't have cameras in them and recording devices in them. Computers were not able to record audio and visual. Now they are. Everything you do is being recorded. Not only that, when I first presented this slide ever, the girl in the front of the room was recording it. I didn't know. And I said, there's a really good chance your phones are listening to us right now. And Katie said, there's a 100% chance because I'm recording it. And I looked down and sure enough, she had been recording it. Not only that, she had told me about it and I just forgot. You know how many times people have done something stupid because they themselves started recording it and forgot what they did? So just assume that everybody's going to know what you're doing. Next is Ross's duties and Bernard's don'ts. If what you're doing doesn't fall in line with these, you probably shouldn't be doing it. Then you need to take action. You need to implement your decision. Look, you're the one who's making the action. You're the one making the decision. So you need to be responsible for your actions. If you don't, you're going to lose integrity. If you lack integrity, the next time around, it's going to be a lot harder for you to enforce your decision. Acknowledge the impact of your action. Look, in the real world, and even in the idyllic world, from time to time, your decisions are going to screw some people over, and that's unfortunate. But instead of saying, not my problem, what you have to do is try to relieve their pain somehow. And 9 times out of 10, just acknowledging that you did it goes a long way. And then follow through. So what that means is if you tell your boss you're going to take an action, fucking do it. Look, if you're not the guy who actually gets things done and your boss has to keep checking on you, he's going to stop giving you work and he's not going to promote you. So you have to make sure you actually follow through. Communicate. So this one's frustrating for me. I do have a bit of a speech impediment, but I've also dealt with plenty of people who there is no level of effort that you can reach where they will listen. They exist and they're frustrating. So what you have to do is you have to make it clear to everybody else you have gone out of your way to be clear about what's going on. So clearly explain the decision and why you're doing it. So that means you email as many people as you can. You have big meetings with a lot of people in them. You don't use technical jargon unless you absolutely have to. Be open to feedback. Look, if you're affecting a lot of people, you're going to get feedback. And some of it's not going to be good. But the thing is, some of them are going to have a point. And you need to absorb that point. Show empathy. Sometimes you're going to screw people over by accident. Look, we know you didn't mean to do it, but you did it. So you at least need to apologize. And if you can, try to make it better. For example, I have a little girl. She's about 3 years old. She has an older brother. He's 6. He's got other friends that are also 6. My daughter is a little juggernaut and doesn't care that they're twice her size. She wants to wrestle and fight with them. Time to time, the bigger boys will shove her down. She won't like it and she'll cry. One of the little boys clearly was just playing with her, clearly just got too rough, didn't feel he needed to apologize. It's not the case. He needed to apologize. It was an accident. He wasn't in trouble, but he still needed to apologize. That's what's going on here. Sometimes life just deals some people a bad hand. If you have any involvement in that bad hand, even if it isn't really your fault, you at least need to acknowledge that it's unfortunate for them and that you're sorry it's happening to them. Now, to be a good person, you should make some effort into making it not so bad for them, but at the very least, you need to acknowledge that it is bad for them. All right, the next and last thing we're going to go over is confidentiality. So these are the four main types of confidentiality. There's privileged information. This tends to be attorney-client, doctor-patient, not really something you guys need to worry about. The next is proprietary information. This tends to be business strategies, customer lists, customer contact information, verbiage within contracts, non-disclosure agreements, IP, stuff like that. Then there's trade secrets. This tends to be like Coca-Cola's formula, insider knowledge, other company secrets. And the last is CUI. This is my bread and butter here at URI. Controlled unclassified information. This is defense-related sensitive information. This is not secret information. It just pertains to sensitive unclassified information requiring safeguards. So I'm going to oversimplify it a little bit. If you get money from any organization, be it a government organization or a private entity or some nonprofit, they're paying you, and they get first dibs on that information. That's what the Navy's doing. They're paying for it. They want first rights to it. And some professors across the U.S. thought they were really cute and would say, yeah, this is the Navy's information, and then they would give it to whoever asked for it. And that's not really what the Navy wanted. And so now they have this term, controlled unclassified information, forcing professors and students to, number one, not accidentally sharing information. You know, I'm doing air quotes over here, but a lot of the accidental sharing that professors had been doing with this information was very clearly not an accident. It would be akin to you walking into a Starbucks with a giant stack of papers, leaving them on a table and wandering away. No, you didn't share the stack of papers with people, but you were being so irresponsible with them, only an idiot would think that nobody would shuffle through them. So what companies like to do is demand confidentiality, especially when changing jobs. And to a certain extent, this is required. There have been instances where companies went to court about this and they won. However, there's a lot of caveats to that statement. So one of the examples is a lawsuit between Uber and Google. I forget what the direction was, but there was an engineer working for one of the companies on the self-driving car. And that employee who knew all of the code by heart quit one company and moved to the next and more or less just rewrote the code. Well, the thing is that code is copyrighted. So the other organization owned it. And so what he did was inherently illegal, not because he was switching companies, but because he took information that belonged to one company and handed it off to another. That's illegal. But you getting up and moving to a different company is not. And so the only time a jury is really going to side with the company is in instances where very legitimate NDAs were signed. You can get around an NDA if it was signed under duress or if it required some level of illegalness to it. If you are explicit about the specifics within the company. So in the case of the guy going from one company to the other and rewriting the code, he was giving explicit information. That's what actually got him in trouble. If you bring something with you from one company to another that has IP on it, you still need to pay to use the IP. If you refuse to pay to use the IP, you can get in trouble. If you are genuinely worried about this, I would consider getting a lawyer. Look, to get a lawyer to look at a contract for an hour or two, it's going to cost you $400, but switching jobs is probably going to cost less than that. So, I mean, Switching jobs will probably pay you way more than that, so it's worth doing. However, as a general statement, you should be maintaining confidentiality. Part of the reason you do that is there's inherent value in somebody who's confidential. I know secrets. I keep my mouth shut. So people are very comfortable sharing those secrets with me. I can make actions to protect myself based off the information that's provided to me. However, if those people who are sharing the secrets with me realized that I was telling my neighbors about it, and that my neighbors were telling people, I would no longer hear the secrets anymore. Now, the reason I bring this up, and I just went over the main things that you need to protect yourself against when it comes to switching companies, but companies try to use this future employment clause. And the only instance where this future employment clause really works is when you have secret trade information. And it only applies in certain situations. Companies try to get this to be a blanket statement for all companies moving forward in your life, and it's not allowed. This is a very common scare tactic. You're going to graduate soon, and you're going to see this in some of your contracts, and you need to be prepped to deal with it. This is just a plain old scare tactic. It's extremely difficult to enforce, and it tends to be illegal. If you are working for a company with a clause like this, then they are most likely unethical in several other areas, not just in the contract. And the non-compete statement, or the future employment statement, needs to be a reasonable statement. So it needs to not be more than what is required to protect that business. Not make the life of the employee harder than reasonable. Not be hurtful to the general public. In addition to that, it needs to have a defined time limit. It generally is about 6 months to 2 years. The only time the 2 years is really enforceable is if, you've been with the company for 20 years, you personally know the formulas by heart, you know how you can recreate the software with your eyes shut. Anything more than 6 months, I wouldn't trust the legality of the statement. What some companies like to use is the term forever, though, and that is illegal. That's called indentured servitude. You're only allowed to work for us, and it's illegal for you to work anywhere else. It's illegal. They can't enforce that. And there also has to be reasonable geographic restrictions. So they're allowed to say 5 miles from previous work location. They're not allowed to say the entire city of Boston. Further, typically, especially in the Northeast, it's not 5 miles from the previous work location, it's 5 miles from the headquarters. So if the headquarters are in New Jersey, then don't fucking work in New Jersey. You're safe to work wherever you want in New England. And lastly, you're never required to share where you're going. It's none of their business. Again, this is just a scare tactic. You can just say you're quitting. Where you're going is none of their business. And if they try to enforce this forever clause, take them to court.